Hello friends, welcome to Hunt Electronics, and this is your friend Shakib with a new technical topic, that is a selection criteria of microcontroller, or in other way we can say that what are the steps to select the microcontroller for your project. So the microcontroller is a heart of your project. So one should know which is the best microcontroller and what are the various steps should we follow to select the microcontroller. So there are 10 different steps which should be followed for a selection of a microcontroller. So the first one should know the application of the microcontroller. Second, the best suited architecture. Third, one should know the bit size of the microcontroller. Fourth, which type of networking you are going to use in the project. Fifth, what will be the operating voltage of the microcontroller. Sixth, the number of I/O pin required for your project. Seventh, the size and the package of the microcontroller. Eighth, what will be the memory size of the microcontroller. Ninth, what will be the total power consumption. And the last, at what end you are going to get a support from a various website for the microcontroller. So my dear friends, these are the 10 steps which one should follow to select the microcontroller. Let us see each step in the details. So as I told you, the first one, the most important, is the application of the microcontroller. The first thing that one should do before choosing any microcontroller for a project on an embedded system is to acquire a deep knowledge of the application for which the microcontroller based solution is required. Next, one should have the understanding the particular feature that the microcontroller will be used for in a project. Next, make the list of all the external interface the microcontroller which needs to be supported or going to be controlled. And the single unit of microcontroller should support all the devices which will be utilized to perform the task involved in many decimal number. And if you will be able to understand how the microcontroller will be utilized in your project, then you will be certainly make the right decision. So the next one is the architecture. The term microcontroller architecture means how the microcontroller is designed internally. So generally there are two major architecture that are utilized in designing of the microcontroller. One is Neumann architecture and another is a Harvard architecture. So the Neumann architecture make the use of a sample process to transmit the data and collect the set of instruction from the memory. Thus, the data transfer and instruction collection cannot be done at the same time. So generally they are scheduled. So that is somewhat the complication in this architecture. The next is the Harvard architecture, which uses a separate route for a transmission and a collection of an information. So it has got a dedicated parts. So it is somewhat easy. So the Harvard architecture is based on a reduced instruction set system. Thus, they can carry out a better instruction with a lower cycle as compared to the complex instruction set, that is CICS system, on which the Neumann architecture is used. So as per the requirement, you can go for any one of this architecture. The third, which is most important, that is a bit size of the microcontroller. So there are many bit size available in the market for different microcontroller over here. So the microcontroller comes in the different bit size that can be either 8 bit, 16 bit, 32 bit or a 64 bit. And at present, I think that is 64 bit is the maximum bit size possessed by any of the microcontroller. The 8-bit microcontroller denotes the every instruction address or a variable in a 8-bit. One of the main indication of the bit size is the memory capacity of the microcontroller. For example, The 8-bit microcontroller will have a 255 unique memory location, while a 32-bit microcontroller will consist of 4294, 967, 295 unique location. So it is very essential to choose a microcontroller with a bit size that meets the data to be processed. So as shown in the figure, you can see there are different, and the choosing the right microcontroller with the right bit size is very important. The next is, as we discussed, it is a networking. So the which is very important, where you are going to interface a different sensors, actuators, you are going to communicate with the cloud. So which type of the communication, it depends upon the networking. So the communication among the microcontroller, sensors, actuator that will be used for the project might need the use of a network between the microcontroller and the communication. For example, to connect the analog sensor to the microcontroller should have the enough ADC, or you can say a DAC. Also, the change of a DC motor might need a PWM of an interface. So there are various networking interface like I2C, UART, PWM, ADC, SPI, USB. So as per the requirement, you should select the microcontroller for which type of networking you are going to use for communication purpose. Next, that is the operating voltage. So the operating voltage means the voltage level at which the system is built to operate. The operating voltage at a time decide the logic level at which the microcontroller will communicate to make up the entire system. So below you can see there are different types of a level. Over here between 2 to 5 is considered as a high, or 0.8 to 0 is considered as low. The another which accept the TTL gate, that is 0 to 0.4 as a low, and 2.7 to 5 as a high. So depending upon that. Currently, the 5 volt and 3.3 volt voltage are the most admired operating voltage for the microcontroller, and your decision should be based on this voltage level. The most important, that is the number of IO pins. The number of IO or a general purpose pins present in the microcontroller is the most important factor that will surely influence the choice of the microcontroller. If a microcontroller possesses all the features that we have mentioned but does not have the required IO, then you can't use that microcontroller. One of the most important thing that a designer should decide that the number of IOs which they are going to use at present, and the number of IO should be kept in a spare for a future implementation if they want to improve the advanced feature, if they are going to add some advanced or going to modify some of the project input output in the feature. So it should not happen that at present you have selected a microcontroller based on a number of input and output, and in future if you want to add some more additional feature to the system and the IOs are not sufficient. So the designer should always think ahead of the time. The next, which is most important, is the memory. So there are various kind of memory associated with microcontroller like RAM, ROM, EEPROM. The memory of the microcontroller holds the firmware of the microcontroller. The data memory is utilized during the runtime, and all available data generates because of the processing among the other activities during the runtime and are stored in the data memory. Thus, on the basis of the complexity of the computation and the occur during the runtime can be used to determine the amount of memory needed for the microcontroller. And the next is the package size. So this is very much important, one of the parameter, that is the package size. That means the form factor of the microcontroller. So while designing the actual PCB, the designer should think of the which size or package. So depending upon that, the area required on the PCB is very important. So generally the microcontroller comes in the package that varies from QFP, TSOF, SOIC, SOP, and the regular DIP package, which makes the arrangement on the breadboard very easy. So depending upon the size of the PCB, how you are going to arrange on the PCB board. According to that, you should select the package. Therefore, it is a crucial plan to way ahead of the time about which package will be the best suited. So below in the picture you can see there are the different packages, the shape and size. The same microcontroller with the same IOs with the same memory are available in the market. The next, which is very important, that is the power consumption of the microcontroller. This can be the crucial factor for the most when selecting a microcontroller, especially if you are going to make a project which will be operating on a battery. So there are the various applications which nowadays you are developing in day-to-day life, which are like a IoT device, which are wireless, which will be the battery operated. So the power consumption is very important. Make sure that the microcontroller are using satisfying the power requirement of your project. So there are various model manufacturers which are developing a microcontroller with a different range of voltage operating, like from 1.8 to 5.5. There are different like a Texas, Silicon, Atmel, NXP, etc. And you can see the current rating of in active mode, in the standby mode. So there are different. So especially when you are designing the nowadays we are developing a new AV vehicles, bikes, and these which are operating on the battery. So you should get a more and more battery backup for the system. That's why we should select a microcontroller on the basis of an power system. So power consumption is very important. Very important a power factor which should be considered while designing. And the last but not the best list, that is a microcontroller support. The microcontroller you choose to work with should have the enough supports like a code sample, reference design, and if possible the huge online community. Suppose if you are using a new microcontroller of any new manufacturer but it does not have any supporting code or reference, this is going to make a headache for you in the future. So if you are working with a microcontroller first time, then you can face a very difficulties and challenge. Using the resource can help you to overcome them very easily. So there are very online communities, or there many sample codes are there which you can just download and utilize and modify for your project. Your microcontroller should have a good emulation kit. Okay, so for each microcontroller which you are going to select, it should have a good development kit over there where you can very easily practice and get familiar with that tool change and a development process of the microcontroller, and later on you can design your own PCB depending upon it. Most microcontroller have a number of choice of a compiler, example codes, and debugging tools. And it is the most important to make sure that all the necessary tools are available for the parts. Without the right tool, the development process could not be easy, or it can be a difficult and expensive in the future. So my dear friend, that's all for today. And for the more technical session like this, please like, share, and subscribe to my YouTube channel named as Hunt Electronics. Thank you.